Hi, welcome back to Chemistry Laboratory. This is Dr. Rajshekhar Medidi, Associate Professor, Kipridaya University, Somali region, Ethiopia. Today we'll discuss about the new experiment, that is determination of citric acid in the wine sample. So this is the wine sample present in the laboratory. Today we'll discuss about the determination of citric acid present in the wine sample. This wine sample generally contains other acids also, that is malic acid, succinic acid, tartaric acid and citric acid. Very small amount of citric acid is available, may be present in the wine sample, that is around 500 mg per liter. So let us determine the amount of citric acid present in the wine sample. If you see the procedure for the determination of citric acid in the wine sample, the aim will be to determine the amount of citric acid present inside the wine sample. So the apparatus will be normally the burette can be used, pipette can be used, conical flask, beakers, volumetric flask, glass rod, analytical balance. All these apparatus can be used. And coming to the chemicals, we need to have the same chemical, that is the sodium hydroxide of 0.1 molar is used as a chemical. And coming to the indicators, we can use indicator phenolphthalein, which produces the colorless in the acidic medium and converts into pink in the basic medium. That is the end point. We have to take the 10 ml of this raw wine sample into the volumetric flask, 100 ml volumetric flask, and fill the flask with the distilled water up to the mark. After complete dilution, from that 100 ml of volumetric flask containing the diluted wine sample, we have to take 25 ml of the sample into the conical flask and already fill the burette with the 0.1 molar sodium hydroxide solution. Now the conical flask containing the wine sample of 25 ml is allowed to add the 2 drops of phenolphthalein indicators. It forms no change in color because phenolphthalein doesn't produce any color in acidic medium. Then we have to titrate the wine sample containing the acid, citric acid, with the sodium hydroxide from the burette. Slowly when you titrate the solution, at one point of time, the color of the volumetric flask converts into from colorless to pink. That indicates the end point. That means that all the acid present inside the conical flask will be neutralized by the addition of sodium hydroxide from the burette. And finally, the reaction ends with the pink color. This is about the demonstration about the determination of citric acid present inside the wine sample. Now we'll go for the experimentation visually, practically, and then we'll go for the calculations on the board. Yes, this is the titration bench. Now we will perform the experiment. That is, this is the wine sample. So now I will take 10 ml of this raw wine sample into the volumetric flask, which is 100 ml capacity. So now I will pipette out the 10 ml of the wine sample with the pipette. Already washed pipette. It is already washed. Yes, this is 10 ml of the wine sample. I am taking it to the volumetric flask. Right now, I will dilute this raw wine sample up to the mark by using distilled water. This is the distilled water. I am diluting now. So it should be diluted well. Yes. Now yes. So this is the 100 ml of the given wine sample. Now from this sample of wine, we have to take 25 ml of this sample for the titration performance. Right? So now I can use the same pipette. So this is 10 ml pipette. I can use 2.5 times. Yes, this is 10 ml. This is 5 ml. So now this is the 25 ml of the wine sample. Okay. Now we take the burette containing sodium hydroxide 0.1 molar. So this is the burette which is already washed with the sodium hydroxide already. This is the new 0.1 molar sodium hydroxide solution. I can fill this into the burette now. Yes. So this is excess. I am making it up to the mark. Yes. Now it is up to the 0 mark. So now this is ready. And now I have to add 2 drops of phenolphthalein indicator into the beaker. This is phenolphthalein indicator. Two drops is added. Now I will make it on. Sterilise rotation. Let us start the titration process. Now this is colorless solution because phenolphthalein doesn't exhibit any color in the acid medium. Now when the reaction completes, it becomes neutral, then changes into basic, then color changes from colorless to pink. Let us see now. Titration is going on. We have to add slowly. The reaction is very fast. The pink color is observed very accurately. You can see for every drop, the color is coming and going. The pink color is coming and going. Yes. Yeah, this is the point. You can see the color completely, the color change from colorless to pink color. So observe the value here. It is 1.4 ml. So we got the value, the color changed from colorless to pink at the volume of 1.4 ml of sodium hydroxide. So 25 ml of the wine sample consumes 1.4 ml of the sodium hydroxide 0.1 molar. Now this is a reaction and point. Now let us perform the calculations to find out exactly the molarity of citric acid present inside the wine sample. Let us understand the calculation part. Determination of citric acid in wine sample. This also comes under the real sample analysis calculations. Reaction is 3 moles of sodium hydroxide reacts with 1 mole of citric acid. As per the stoichiometry, N of base is equal to 3N of acid. Number of moles of base is equal to 3 number of moles of acid. So as per the calculation, concentration of base into volume of base is equal to 3 times concentration of acid into volume of acid. That is 0.1 molar sodium hydroxide is taken, and volume of base is 1.4 ml, that is sodium hydroxide ml 1.4, and 3 times of concentration of acid into 25 ml of the acid is taken. Now the concentration of acid is equal to 0.14 by 75, that is equal to 0.0018. So we have taken 25 ml of the sample from the 100 ml of the flask, that is 0.0018 into 100 by 25 is equals to 0.0074 molar citric acid. That means very small amount of citric acid, that is 0.0074 molar citric acid is present inside the sample that we have taken for analysis. This is about the determination of citric acid from the wine sample. Thank you.